Welcome everyone! Today we're going to be building a side-scrolling strategy defense game from scratch in MapleStory Worlds. Let's take a look at what we're going to build today. Alright, so we have our defense world framework here, and if we press game start, we can see it down at the bottom. We have our units that we can deploy. So let's deploy our tiger here. Let's deploy maybe a bear. And notice the mesos on the top right. We can spend those mesos to spawn units into our grid. Panda's a little bit faster, but we have on the right side our enemy AI automatically spawning enemies on the right side to counteract us. But we're gonna spawn a couple more. And here we have our victory screen. We can go on to the next stage, or we can go back to the main menu. For now, we're gonna go back to the main menu. And we have the ability to edit our decks. So if we click edit decks here, we can see that we have 4 different units at the moment. Each of these have different configurable stats. We saw that we have the tiger, bear, and panda in our loadout. We can change it so that we have the giant in our loadout. So let's replace our bear with the giant and click OK. And when we press game start again, now we have the tiger, giant, and panda instead of the bear. So if we can click on the giant, you can see that our giant is spawning in. We can also spawn in some pandas here. And if we click next stage, we can see that our background is changing according to the stage count. So let's spawn some pandas in. And if we click next stage again, we have another stage here. And then continuing on. And stage 4 is the final stage in our world, but we can of course add more through our configurations. But for now, let's see what happens when we lose. It does get successively harder and harder as we go along. And we've lost, and we have the ability to retry this level or go back to the main menu. Okay, so that is the world that we're going to be building today. But before we start writing the logic, we first need to build the stage. So in this section, we're going to configure our world map and make our player avatar invisible. Since this is an RTS style game, we're going to place our player and enemy bases with custom spawning gers. So let's get our environment ready. So let's start by setting up the map and the layout of our map. So notice that we have 2 maps. We have a title map and we have a main game map. And let's open up our map editor by doing Control Alt and 1. Alternatively, we can go up into Window and open up our map list here. So we have our title and we have our main game. Our title is set as our starting map, so this is where our players will start. And then through code, we are going to transition them into our main game. So if you click on our main game and load this in, and as you can see, here's that tower defense setup that we saw earlier. So let's go back into our title. And if you take a look at our map, we can see that the map style is our maple tile. And same thing goes with our main game. This is also set up in our maple tile. We can see 3 different types of tiles. We have our maple tile, our rect tile, and our side view rect tile. For the differences between all of these, I encourage you to take a look at our promo tutorial series. But for this defense game project, we're going to take a look at the maple tile, and we're going to utilize the maple tile for our world. So for the purposes of demonstration, let's create a new map here. Let's click create new map, and that will create a new map with an automatic name. Let's load this map in. And let's assume this will be our new map here. We're kind of going to be cloning our main game map and see how that's set up. So the map style, as I mentioned, is in maple tile. And the setup for the map is very, very simple. So let's just click on our paint box here. And if you go into our preset list, we can see a list of all the different tiles that we have to choose from. So let's choose, let's say this one here. And let's make a drag. Let's drag this out. Sorry, there was a bug. Let me restart that. And let's click on our paint box and let's drag this out. And there is our platform. On the left side, we're going to have our home base, and on the right side, we're going to have our enemy base. So under our map, let's create 2 empty entities. So let's right click and let's click create entity and create empty. Let's rename this our home base, and let's create another one. Let's rename this enemy base. For both of these, let's add a sprite renderer component. And for the sprite RUID, let's select our towers. Before we choose the sprites for our bases. Let's reposition our tiles so that they are on opposite ends. Perfect. And then for our home base, let's go into our AI lab and click on Research Search. This will allow us to search for and navigate through our vast array of sprites and resources that we have, from BGMs to voices to effects, animations, resource paths, etc. So from here, let's search for our home. Maybe more than home, let's search for house. Let's pick one that looks kind of like our own home base. Let's go with this one. And let's copy the sprite RUID here, and we can paste that, making sure that we are selected on our home base. Paste that into the sprite RUID field here. Doing that, if we head back, we can see that we do have this sprite right there, and that one's actually a little bit too blocky. So let's pick a different one. Let's go with that. It's a little humble, but it'll do. Let's change our home base to this one here. Let's shrink it down just a little bit. And then let's click on Flip X so that it's facing the other way. And let's choose one for our enemy base as well. So for our enemy base, let's go with this one. So we can copy the RUID here as well and paste that into the sprite RUID field there. And then let's decrease the size again to match roughly the size of our other base there. And let's also create an entity as child for our portals. So let's create another entity as a child. Let's bring this about there. And then let's add a sprite renderer for this. And for our sprite renderer, let's search for a portal. And for this one, we're going to search for an animation. Let's go with this one. And let's paste this into our sprite RUID field here. Let's increase the order in there so that it comes up in front. Let's decrease the size. And there is our portal for our own monster entities. Let's rename this to portal. Let's duplicate this and do the same thing, placing this under our enemy base. Let's bring this over to our enemy base side. Let's rename this so that this is just portal. And let's replace this with a portal that looks more like a monster portal. I'd say this one looks pretty good. So let's copy this and paste this into the sprite RUID field here. And there is our monster portal. And with that, we have created two portals. We have set up our home bases and the enemy base, and we've created a portal for each side. We can also change the background. Our background will be adjusted through code, but just for the sake of making it look a little pretty, let's go to our backgrounds. We can choose any one of these here. Let's go with maybe this one. Now, we had created these portal entities that we're going to be spawning our units into, but we're actually going to rename these to spawn location. And we're going to do this for both of them. So this one and this one. And the reason for this is because we're going to be searching directly for these portal entities, these spawn location entities, through script. And we'll get into that in just a moment. But for now, let's make sure that we have renamed these portals to their proper names so that when our script looks for them, that they are actually there. And there we go. We have our background, we have our base, and then we have our enemy base. And that concludes the setup for our map. Now let's move on to the setup of our player character. If you remember, this game doesn't actually utilize any player character at all. So we actually need to completely hide our player character so that it's not actually interactable and visible in our world. So let's go into our default player and let's inspect our properties. Now, if we collapse all of our components, we can see that we have only a little bit of select components. Normally, when you first create your world, you're going to have a lot more components here. But we're going to get rid of all of the components that are non-essential to our game. So that includes anything visual. And we're just going to keep everything that we need just for our game. So that will just be our camera component so that our camera is fixed on the screen. We're going to keep our player component so that our code is able to identify who the local player is. And we're going to keep our player controller component so that when we transition our map, we have the ability to transition our player through this player controller component. So these are the three essential components that we need, of course, including the standard transform component and then any model extension information. So all of the other components we're going to remove because we don't need them. The map finder component is our own custom component, and we're going to get into what that is and why we've added this to the player in the corresponding section. But for now, we're going to ignore this map_finder component, and we're just going to imagine that these three are the only components that are attached to our player. Okay, so at this point, we've got our map set up with our base, our portals, and we also got our player set up to make sure that it's not visible and it only has the components that we need for our map. Now, the final piece of this puzzle is to actually connect some behavior to our bases. So we need a controller and a component that will be able to handle the spawning of our players or our enemies onto these bases. So our controller component will be the base component here. And we've already created this base component, but you can right click and you can go into scripts and create component to create your own component for this base. But in this case, we've already got a base component. So let's just make sure to attach this base component to both our base and the enemy base. And we're going to make sure that isUser is unchecked for the enemy base. And we're going to get into each of these properties in just a moment, but let's double click to open up base component to take a look at what's going on. And we're going to highlight and focus on a couple of these methods and a couple of these properties. For now, let's focus on this first property isUser, and we just unchecked that for our enemy base. And this property is simply just to identify which one is the enemy base and which one is our player base. The second property we want to highlight is the HP, and this just holds the total HP for our respective bases. Next, we have our spawn location, and this is going to be referencing the spawn location in our home base and our enemy base that we created earlier. So that is all the properties that we need to take a look at for now. The other properties we're going to look at in the future sections. The isUser property is going to be relevant in the initialize method. So in our world, we're going to be reusing the main game map over and over again rather than recreating a new map for every level that we have. So what that means is we need to reinitialize the base in our maps to their default values. So we are checking for the isUser property to double check if we should initialize the values for the user or if we should initialize this base as an enemy base. There's of course global and more common properties like gold and gold timer that is going to be universal for all bases. We're also going to be searching for the spawn location, and this is why we had to make sure that the name of our portals or the spawn locations are exactly so. And spelling uppercase and lowercase do matter here, so please double check to make sure that you do have the proper naming convention and spelling for spawn location, because in here we are searching directly by name under our base component entities. Next up, we have our spawn location, which is going to be relevant in the spawn unit method. Our spawn unit method is going to be able to actually spawn the units in to our map based on that portal position or that spawn location that we referenced earlier in init. So we're going to spawn in the unit from our pool, and we're going to get into what pools are. Think of them as kind of warehouses for recycling entities. So rather than creating and destroying entities over and over again, which uses a lot of memory, we're going to essentially reuse the entity over and over again. So that is what the object pool logic is. It's an optimization technique to save on memory costs, and we'll get into this in a future section as well. Once we have our units and we have set them to the spawn location, then we're going to initialize this unit. So now that we have our unit, we have to be able to take damage, or the unit will be dealing damage to the bases, or the enemy units will be dealing damage to us. So we need a damage function, and that of course will be relevant to the HP property that we have. So we're going to be passing in a certain damage value. We're going to subtract that HP by the damage value. If the HP is less than 0, then we're going to call the destroy method. The destroy method is going to show the failure window or the defeat window if this base is not the user, and then we're going to disable this entity. And that takes care of the setup for our map. We've set up the bases with its base functionalities for taking damage, for its HP values, and for spawning units in. So now that we have a solid battlefield with functional bases ready to spawn units, in the next section, let's dive into unit creation and learn how to manage stats and animations using a highly scalable, data-driven dataset system. Rather than hard-coding dozens of individual characters with messy conditional scripts, we're going to build smart data-driven frameworks. We'll set up custom datasets for unit statistics and animations, construct a modular unit skeleton, and create state tracking scripts to manage movement, hits, and transitions. Here's our strategy for datasets. Instead of duplicating components, we'll use a single common logic script and drive individual unit behaviors using database tables. So we're going to hold a couple different datasets here. If we check our My Desk folder and we go into the dataset folder, we can see that we have 5 different files here for datasets. 4 of these are going to be pertaining to our units. This 5th one, UI locale data, is going to be related to localization, so we can ignore this one for now. Our unit data is going to hold game stats, things like our usable flag, our render ID, the name, cost, HP attack, move speed, things like that. We also have our skill data. So if we look at our column number 8 of our unit data, we can see that we have a column for skills and we have an ID. This ID corresponds to our skill data table. So we can see on the left side, we have IDs here, and we have an effect RID related to these skills. Next up, we have our unit render data. Our unit render data houses state-specific animation RUIDs, such as idle, moving, attack, dead, etc., and the precise attack pick frame timing. Next, we have our stage data, which is going to be pertaining to the data for the stage. So we have our enemy units that our enemy will be spawning in. We have our gold per second. We have our enemy gold per second. We have our player base HP, enemy base HP, max gold, and our background RUID. So to hold all of this data, we're going to be creating what's called a logic script. Logic scripts don't need to be attached to a specific entity, and its variables and methods can be accessed from any script in the project. So this becomes very useful for things like storing our data so that our data can be accessed from anywhere. So we're going to be creating our data set logic. We can see in our logics folder, we have our data set logic, and this is going to store and house all of the data from our data set tables. We're going to be writing loading routines inside of our onBeginPlay method to cache our dataset values into tables right when the game starts. So we have our tables for unit data, unit render data, skill data, stage data, etc. Each of our data loading is going to follow a very similar structure. We're going to be looping through our dataset. So for example, in our unit table unit, we have our unit data, which is going to be loading this data table right here, our unit data table. And we're going to be looping through each of the columns in our unit data table. So if you go back, we can see that we have our usable, render ID, name, cost, HP, etc. All of these tables associated with our unit data. And in our dataset logic, we can see that we are loading in that data, and then we're going to be crafting our data table, and we're going to create a key for the corresponding column. So we have a usable, render ID, HP, attack, speed, and there's going to be a certain key that is going to be corresponding to our unit data column name. So for each data key, we're going to be loading the corresponding data for that row and column and grabbing that data. So for example, in our first row, it'll be true, second true, true, false, and true. And we're going to be loading them in one by one into our respective data keys. So our usable data table, our render ID, each of these are going to be loaded in based on the corresponding row. So once we have that data from our unit data table, we're going to be grabbing the name column from that data table and storing that in our unit name variable. And then we're going to be using that as a key to our unit data table. So inside of our unit data table, we're going to be utilizing the name of our unit as the key and passing in the data that we've crafted. Our other data tables are going to be utilizing a very, very similar structure. For unit render data, we're going to pass in that data table name, loop through each of the rows, and create keys corresponding to each of the different column names, passing in that data for that table. And then the only difference will be that our unit render data table is going to be utilizing the index as the key, whereas the unit table is going to be utilizing the unit's name as the key. And this is just for us to be able to easily access this table by our unit name as opposed to an index. Our skill data table is going to be passing in our skill data, grabbing the effector ID and then utilizing the index as the key for that data. And then our stage data table is going to be loading in the stage data table. And then we're going to be loading in each row as the corresponding key. And we're going to be utilizing a slightly different structure here, where in our stage data table, if we go back to our stage data, we can see that we have our enemy unit, and this contains a list of enemy units separated by our comma character. So if you go back to our dataset logic, the loading in for the data is going to be essentially the same way that we have seen so far. When we go down to our unit string, we can see that we are loading in the enemy unit column, but our enemy unit column is going to have multiple entries separated by that comma key. So what we're going to do is we're going to utilize our util logic, and we have our split method, which is going to be splitting up a certain string by a certain separator, and it's going to organize them and return the table after separating them into that table. So it's going to return that table, and we have our enemy units table, and we're going to pass that enemy units table into the data as a key of enemy units. So this is going to be the same structure as this, just a slightly different syntax, where we are assigning the key to the value. We're going to do something very similar. It's just a slightly different syntax, where we just pass in the enemy unit key and then assigning the enemy units table that we created from this split into that data table entry. So with that data, we're going to store that based on index with the data that we've created. So that is all of our data for our dataset logic. Now that we know where the data for all of our units is coming from, let's actually create the model for our unit. So models are going to be essentially blueprints for entities in our scene. So if you go into our world and we hop into our maps here, we can see certain entities. Let's say, for example, in our main game, we have these entities here. Each entity has a list of different components. They might have children, things like that. So inside of our models, we can essentially create a blueprint. We can store and save this entity as a model so that we can create new models based on the saved model settings. So we're going to do something very similar for our unit. So let's hop back into our title and let's double click to open up our unit. So this is going to be the model for our unit. And we can see if we collapse this down, we can see all of the components associated. So first we have our transform component. This is going to store the position and track the position and scale of our entity. We have our sprite render component, which is going to be just housing the sprite RID to render in. And then we have our unit component, which is going to be controlling the behavior for this unit. We have the animation controller, which is going to be handling the animation of the unit. We have our custom state, which is going to be handling the transition between the different states, housing our different states, and the data for our states. And then we have our trigger component, which is going to be managing the collidable area for our enemy for things like attacking and things like that. Okay, so with that in mind, let's first take a look at the animation controller. So the animation controller is going to read the animation RIDs and swap sprites on command. So first we have three properties. We have our renderer property, which is going to be caching our sprite render component. We have our action sheet with all of our animations, and then we have the hit timing. In onBeginPlay, we're going to cache our render property with the sprite render component, and then our change animation method is going to look up the state name in the action sheet property here, and it's going to update the renderer sprite RUID based on the animation name of our action sheet. So this action sheet will be set from our set animation table here, and this is going to be grabbing the dataset logic. So we already went over the dataset and how we cache the data coming in from our data tables. One of those data tables was our unit data and our unit renderer data. In our unit data, we're going to be utilizing the unit name as the key to our unit data and grabbing the render ID. So this is effectively going to be grabbing this column right here from our unit data table. Back into our animation controller, we also are caching the action sheet from the unit renderer data by the unit render ID. So this is going to be grabbing the unit render ID from this table, and that is going to be utilized to grab the corresponding unit render data. So for example, for our first row, for our tiger, we have our render ID of 1. This is going to be grabbing this first column of the idle, move, attack, on hit, etc. These attack sequences here. So in our animation controller, we essentially have all of the animation data and the action sheet for this data. Then our attack timing is going to be the attack pick from our unit data table. All of that data is going to be set from our set animation table. When you change our animation to the animation name, we're going to be grabbing it from the corresponding action sheet that we loaded in from our unit render data. So that's it for our animation controller. Moving on to our custom state, let's open up our custom state script. This will be in our units folder. We have our custom state component here. And our custom state component acts kind of like an active decision maker between the game loop and the passive animation controller that we just went over. So we have two properties. We have the current state and we have our cached animation controller. So that will be the animation controller that we just went over. We have our init method, which is going to set our current state to idle. So by default, it will always be the idle state. And then our animation controller will be cached with our entity's animation controller. When we call change state, we're going to first double check to see if our current state is either attack or on hit. If that is the case, then we're just going to return because we don't want the attack or the on hit animations to be interrupted, whereas the other animations, it can be interrupted. Then we're going to set the current state name to our state name that we're passing in, and from our cached animation controller, we're going to call change animation, which will change the animation to the state name. Then we're going to have our handle sprite animation player end frame event. So this is a lengthy name for whenever the animation is over, do something. So we're going to grab the current state as attack. So if the current state is currently attack, then we're going to change the state to idle. So whenever any animation is over, we're going to check for the current state. If that state is attack, we're going to change to idle. If the current state is dead, then we're going to set the activation status of our entity to false, and then we're going to call return unit on our object pool, which we'll get into down the line. But our object pool is kind of an optimization step to optimize memory so that we're not constantly spawning in units. So it's kind of a way to recycle entities, and we'll get into this more when we go into object pooling. Finally, we have our last component, our unit component here. And our unit component manage all of our stats, our movement speed, and our combat timers. So let's start with our properties. We first have the isMine property, which is going to distinguish whether this unit is an enemy unit or a player unit, because we're utilizing the same component for both enemies and our local player. We're also going to be caching our custom state component that we just went over. We have the direction that we're facing. We have timers to keep track of our attack timer, skill timer, our hit timer, and our damage timer. We have our unit stat table, which is going to be caching the stats from our dataset logic at runtime. Then we have our HP, which is going to be storing our active health and manage any damage that we are going to take. We have various Boolean flags for found, which is going to track if there's a unit up ahead, our waiting, which is going to determine if there's a cooldown active, and our isSendHit Boolean for keeping track of damage that is being dealt. Then moving on to our methods, we have our onBeginPlay, where we will set the state to our custom state. So we're going to cache our custom state property, and then we're going to initialize by calling init. In our initialize method, we are separating our initialization steps based on whether this is the player's unit or if this is the enemy's unit. If this is the player's unit, we're going to set the direction to 1, so we're moving forward. If it's the enemy unit, we're moving backwards. Then we're going to set the corresponding collision groups depending on whether this is the player or the enemy. Then we're going to visually flip our entity based on the direction. If this is the player, we're going to flip X so that it's facing forward. If this is the enemy, then we're going to flip X so that it's facing backwards. Then we have our caching of data for our unit data. We're going to grab the unit data from our dataset logic, and we're going to cache that into our unit stat. Then we're going to call our setAnim table by passing in the unit name. We're going to initialize the attack timers, the HP values to 0 and our maximum HP. Then we're going to set the rigid body component to true so that it can collide with the world. We're going to set the trigger component to true so that it can be detected by other entities and deal damage and take damage. Then we're going to set the alpha to 1 so that it is fully opaque. Then we're going to set the waiting flag for our cooldowns to false because we're not waiting on any cooldowns. Moving on, we have our on update. In our on update, first we're going to double check to see if we have less than or 0 health. If we have no health, then we're not going to do anything. Then we're going to check from our trigger component to see if we found an enemy or not within range of our unit. If so, then we're going to set up our attack timers. In our attack timers, if we are less than our cooldowns, we're just going to idle. Otherwise, we're going to perform the corresponding skill. Depending on if our skill timer is available, then we're going to call skill and perform the skill. Otherwise, we're just going to perform the basic attack when our attack timer is greater than the attack cooldown time. Once the action has been performed, we're going to set the waiting flag to true so that we can continue waiting for our action. Hopping into our attack method, we're going to simply change the state to attack, and we're going to set the hit timer back to 0 so that we can reset the counter for that. And then we're going to set our is send hit to false because the damage has not been delivered. We're going to get into how the damage is actually delivered in just a moment. And then we're going to set our power to the unit's attack stat. And then we're going to play the corresponding sound for our attack. At the moment, globally, it is the exact same sound for all units, but this of course can be changed if you had set up the corresponding data within our unit data table. For our skill, we're going to be doing something very similar, except we're going to set our attack timer to 0, we're going to set our skill timer to 0, then we're going to set our attack state to attack. So we're going to change our state to attack. And we're going to initialize our hit timer to 0, and we're going to again set our is send hit to false because we haven't dealt damage yet. We're going to grab the corresponding skill effects by loading in the unit stats skill entry and utilizing that as the key for the skill data of our dataset logic. And we're going to grab the effect RUID. With that RUID, we're going to play the effect on the player's world position, and we're also going to be playing a global skill activation sound. Then we're going to set our current power to the unit's skill attack data. To actually deal damage, this is going to happen on update. Remember that we are setting the state to attack. So up in here, if our current state is attack and we have not sent the damage yet, then we're going to wait for the hit timer to see if it hits or exceeds our hit timing. So for each of the unit's animations, we have a unit render data and we have a certain attack pick. So this is going to be a certain moment in the attack animation where we actually deal damage. So we're going to wait for that hit timing. And if it's greater than that hit timing, then we're going to first double check to see if a target has been detected or if a target's base has been detected. If a unit is detected, we're going to deal damage to the unit. If a base is detected, we're going to deal damage to the base based on the power. So we have different power values depending on if it's a skill or if it's a attack. And we're going to be dealing that damage to the unit or the base. And then we're going to set is send hit flag to true, and we're going to set the target unit to nil and the target base to nil as well. The last thing we're going to do in update is whenever we take damage, we're going to set the alpha of our unit to a certain level of transparency. So if our change sprite alpha is true and we've changed our unit's transparency, then we're going to wait for our damage timer to decrease and hit 0 or less. We're going to set the change sprite flag to false, and we're going to reset our alpha to 1. Otherwise, we're going to decrement the damage timer by the delta value of our frame. Finally, we have our on damage. Speaking of the damage and change sprite alpha in our on update, we're going to be actually dealing our damage. When we take damage, we're going to change our state to on hit, and we're going to set the alpha of our sprite renderer to 0.4. We're going to set the damage timer to 0.15, which again in update will be decremented by our frame delta. We're going to set our change sprite alpha flag to true so that we can reset our alpha after a certain amount of time. And then we're going to check if our HP, when we deduct health, if it's less than or equal to 0, then we're going to set the enable property of our entity to false, and we're going to change the state to dead. Final two methods to cover will be our onTrigger leave and our onTrigger stay. OnTrigger state will just be setting our found flag based on whether we have a unit component in our trigger body entity or a base component in our trigger body entity. If so, we're going to set the isFound property to true. If the triggering body has a unit component, then we're going to cache the target unit to the unit component that was detected. Otherwise, we're going to set the target base to the base component that was detected on the triggering body entity. And that's it. We've created our units and we set up all the behavior for what happens when we take damage, what happens when we move, all of that stuff. With our combat system synchronized and our units all set up, we now need to make our units fight on command. So next we'll build a robust unit spawn system and set up stage-specific configurations to manage which units spawn on each level. Now we need to handle how units enter into the battlefield. So in this section, let's set up stage data configurations to manage enemy unit spawns and link player input to spawn units on command while checking and deducting our gold. So first up, let's take a look at the data for this section, which is going to be our stage data. We'll double click to open this up and we can see a couple columns here. First column is going to be the enemy unit IDs. So these are going to be all of the enemies that can possibly be spawned at this stage. Next up, we have different separation depending on whether this is the player or the enemy base. But we have our player gold per second, which is going to be the resource generation and the resource accumulation rate for the player. We also have our enemy gold per second, which is going to be the enemy resource generation rate. We have our player base HP and our enemy base HP, which is going to be the maximum HPs for our player and enemy bases. We have the maximum gold that can be accumulated. And then finally, we have the visual backdrop for the stage. So this is going to be the collection of all of the stats for the stage, and each stage is going to have different values, and each stage is going to have different values that's going to load and run in our game. So to load our stage data, we've already gone over this in our dataset logic section, but on begin play, we are initializing all of our data and is loaded into these properties up here. For the stage data table, we are loading our stage data set, and we're going to loop through each of the rows, and we're going to be grabbing each of those columns, and we're going to be adding them into a key value pair, the key being the column name and the value being the value that is grabbed from that column. And we also have a table for the enemy unit. So this particular key, the enemy unit key, is going to be a table of units. And these units are going to be based off, if we go back to our stage data, we can see our enemy unit column here, which is separated by commas. So in our dataset logic, we're going to utilize our util_logic split method to split based on this string. And that's going to return a table of these strings. Once we have that table, we're going to set that to the enemy unit key. And finally, we're going to set that data into our stage data. So we've loaded in our stage data into this property here. Now that we know that, let's go into the actual spawning logic, which is going to be contained within our base component. So if we go back into our base component and we take a look, we can see that on begin play, we have our init, and our init is going to be initializing differently based on whether you're the user or the enemy. If we're the enemy, we're going to set our gold per second to the stage data from our dataset logic that we just went over. We're going to grab our stage logic's current stage value. So if you go into our logic script here, we can see that we have our stage logic, and this has our current stage value here. So we're going to grab whatever the current stage is, and we're going to grab the enemy gold per second for that stage data. So that will be this value right here. Next up, we're going to grab our next unit spawn name, and this is going to randomly generate a unit to spawn in. So if we go into this method here, we can see that we are first grabbing a table of all of the enemy units that we have parsed from our comma separated values, and we're going to select a random integer range based on the table that we return, which is just going to be a string of enemy units, and we're going to randomly return a random unit name. Then we're going to set our HP value to the enemy base HP and our need gold, which is going to be the required currency for the next unit to be spawned. And that's going to be from our unit data. So if we go back into our unit data here, we have the cost value here. So in our base component, we're going to grab the cost value for the unit name. If we're the user, then we're going to grab the player gold per second as opposed to the enemy gold per second. And this is going to be the resource generation rate. And we're going to set our base's HP to the player base HP for that current stage. And then we're going to update the current gold in our UI with the gold value. And we're just going to be just 0 at the start. For spawning units in, for the enemy side, we have our onUpdate method here. And in our on method, we have our autoGetGold. And this method is going to automatically generate our currency. So we're going to increment our gold timer based on the delta of our update here. And we're going to check whatever our maximum gold value is. So as long as our gold is under our max gold value, we're going to increment our gold by that gold per second value that we set. So for the player, it's going to be our player gold per second. For the enemy, it's going to be the enemy gold per second. Once we've incremented that, we're going to make sure that we clamp our value with our current gold with the maximum gold. So it's going to be from 0 to the maximum gold. And this is just going to make sure that we don't get any more gold than our maximum gold value. Then for spawning, if it's not our user, which just means that this is the enemy, then we're going to enemy auto spawn. So that will spawn in that unit name. So we're going to first check if our gold is greater or equal to our needed gold, and we're going to spawn that unit in. So remember that we set up our next unit spawn name in our initializer, and that grabbed a random unit to spawn. We're going to spawn our unit in, and we're going to subtract our gold by that needed gold, and we're going to grab the next unit to spawn after this cycle. So this is going to keep looping in our updates, and we're going to keep spawning in an enemy as soon as we have enough gold to do so. In our spawn unit method, we're going to grab a unit from our object pool. Again, we're going to get into what the object pool does in just a moment, but for now, just understand that it recycles our entities in our game. So we're going to pass our current entity to be the parent of whatever unit we return, and we're going to set the position to the spawn location's position, and then we're going to initialize our unit with our unit name and whether or not this unit is the user unit or if it's the enemy unit. And if we remember, all it does in our init is just going to differently set up our init values, for example, setting our direction, depending on if we're the enemy or if we're the player. And for the player spawn, we have our player request spawn. So the player side is going to be actually spawned by a button. So we need to have a input that actually requests this spawn. And that's going to be coming from our spawn requester that is tied to the button click event. And we're going to get into how this UI cycle and this UI system works. But for now, understand that we have a button on our UI that's going to call our base components player request spawn and pass in the unit name. So once we have that unit name, we're going to be grabbing the unit data and grabbing the cost value for that unit data. And we're going to check if the gold that we have is greater than or equal to the target unit cost. If it is, then we're going to request that we spawn the unit. And this is going to be exactly the same as our enemy. We're just going to spawn in the unit. And then we're going to subtract our gold from our target unit cost. And we're going to update our UI with our new gold value. So if we remember, we're currently in stage 4. If we check our stage data in stage 4, we have just the tigers. So if we go back into our scene, we can see that only the tigers are being spawned in. And from our player side, let's go back into our player. We have the tiger, the giant, and the panda. We can spawn in our player, and for the player side, it's going to be tied to our inputs. So whenever we click, as long as we have enough mesos to do so, we're going to be spawning in our units. Now in stage 4, our tigers are spawning pretty quickly, and this is because we have our enemy gold per second set to 6, and if we check our units data, the cost for the tiger is 5. So every second, we have a tiger being spawned in because we have more than enough gold to do so. So we can balance this and we can update this, let's say 2, so that we only generate 2 gold per second. So that would mean about 3 seconds. We should get a tiger. So now we're getting much slower rate of our tiger, and every 3 seconds we are spawning in a tiger, so it's a lot less. So we can balance it kind of that way if we'd like. So that's it. Our bases are now actively producing units. And next, we'll build a global stage manager to handle transitions from the main menu, load the correct stage data, and manage stage resets. Okay, next up, let's connect our game flow. In this section, we'll build a title screen, set up a teleportation system to move our player camera between maps, and write a global stage manager to initialize our base health and reset stages. So teleports in our game is handled by our teleport logic here. So that's going to be contained within our logics folder. And this logic is going to have two methods here. We have our save local player name to server, which is simply going to grab our user name, which is going to be different from our nickname, which is simply going to be grabbing the name of the entity of our player, which is going to be defaulted to our user ID. So we're essentially just grabbing our user ID here for our local player. This is just to allow our server to know what our local player is. This is especially going to be specific to the single player context because on the server, everybody is a local player. But because this is more a single player, we're just going to let our server know that our local player is going to be this user. Then we have our teleport method, which is going to just grab our entity based on that user ID that we saved to the server. And we're going to grab our map name that we're teleporting to. So if our map name is title, then the path that we're teleporting to is going to be maps title. So that's going to be maps and title. So we're grabbing this entity path here. If our map name is main game, then we're going to be grabbing maps/main games. That will be this scene here. Otherwise, this is going to be an invalid map name, and we are going to ask him to check again. Once we get our map path, we're going to use teleport service to teleport our entity to our target path. So we have a player entity that we've grabbed, and we have our map path. Now it's important to note that our teleportation will only function properly if we have a player component and a camera component attached to it. Otherwise, this will just be treated as any other entity and it'll just be moved to the target path, but our camera won't be moving with our player. So it's important to make sure that we have both of these components so that when our client is transitioning into the target map, our camera is also moving with it. So let's start our flow from our title scene. And in our title scene, we have our UI here for the title. Let's switch to the title group. And this is what we see when we start the game. So in our UI, we have a couple things. We have our game start button and we have our UI edit deck button. The text in our UI is a little bit strange, and this is because we are utilizing this as a key. So if we check our properties here, we can see that we have is localization key checked. So this text here is actually a key that will check our UI locale data. So if we go back to our property, we have UI underscore edit deck. So UI underscore edit deck is going to be right here. And in Korean, this is the text that will be displayed. In English, this is the text that will be displayed. So this is just simply for our localization purposes. We are utilizing our text as keys so that they just auto-translate utilizing the localization table. So with that in mind, we have our two buttons that will be triggered, and we have our main UI title, which is just a text component with the Sprite UI renderer. So we'll get into the actual edit deck button here, but we're going to focus in on the game start. So we have a logic script called UI underscore title, which is going to be managing this UI. So if you double click to open this up, we have our properties that are linking to all of the different buttons that we have. So we have our title, which is going to be the main group. We also have our start button, our edit deck button, and our edit deck pop-up. So let's first just take a look at the start button, because right now we're just focusing in on the flow between our various maps. We'll get into the edit deck button and the edit deck pop-up in a different section. So in on begin play, we have our game start button, and we have a connect event, which is going to connect our button click event to our game start button. And the behavior for when it's clicked is going to be our enter main game method here. So if you open this up, we have our teleport logic and our teleport, and we're going to pass in our main game as the scene to switch to. So going back to our teleport logic, remember we are passing in the main map name, and because we are passing in main game, we're going to teleport our player entity to the main game map. So we are teleporting into our main game, but what actually handles the initialization and start of the level? Well, we have our stage logic script here. So if you double click to open this up, remember that this is what we were referencing in our base component. So in our base components initializer, we were grabbing our current stage name so that we know which gold per second generation value to get from our stage data. So our stage logic is going to be handling all of the base behaviors for our stage management. So in our stage logic, we have our current stage value, which is just going to keep track of our current stage. And we have our Boolean flag for whether or not our stage has started or not. We have two important methods here. We have our stage reset, which is going to reset our stage. So we're assuming that our stage has been completed, or we're going to re-enter the stage because it was used in a previous iteration. This essentially allows us to use the same map over and over and over again by reinitializing all of the elements in that map. So we have our base and our enemy base. We have return all units for both bases. So in our return all unit method for our base component, we are going to loop through all of the units and we're going to return our units to the object pool, which is just going to hide them. So hopping back to our stage logic, we're going to reset our bases. We're going to initialize our base and our enemy base. We're going to set the stage background, which is going to be the background of the current stage. So we're going to grab the stage data and we're going to set it to the background RUID. And then we're going to call set stage state, which is going to set our Boolean flag is stage start to the value of the current stage. So whether it's currently active or not, we're going to activate it by setting this flag to true. Finally, we have our update stage number text, which is just going to update our UI to the corresponding stage number. Next up, we have our open next stage, which is just going to grab our stage data coming from our dataset logic. We're going to grab the number of our stage, and we're going to double check to see if our total stage count is greater than our current stage. If so, then we're going to increment our current stage, and we're going to call game logic save last stage to the current stage, which is just going to allow users to return to our game and resume their stage progress from where they last left off. And then finally, we're going to call stage reset, which as we saw is just going to reinitialize our game. So we know that our stage reset essentially just starts our stage, but what actually determines and calls the beginning of our stage and calls stage reset? Well, on our default player, we have our map finder component. So if you double click to open up our map finder, this map finder is essentially going to utilize our handle entity map change event to listen for whenever we change our map. So whenever a default entity changes maps into the title or the main game, we're going to execute some sort of behavior. So if we enter into the title scene, then we're going to show the UI for the title, we're going to hide the main game UI, and we're going to hide the result UI, and we're going to play this BGM. If we're in the main game now, we're going to show the main game UI, we're going to hide the UI title, we're going to call UI main game deck init, which is going to initialize our deck. We're going to clear all the objects in our object pool, and we're going to call stage logic stage reset, which as we saw, initializes our stage and begins the game. Finally, we're going to call sound service to play our game BGM. So we know how the game starts. How do we know what happens when the game ends? Well, in our base component, whenever we lose HP, we're going to destroy our base entity, which is not actually going to destroy it. We're just going to set the activation status to false because we're, again, reusing this stage. And we're going to call stage logic set stage state to false. If we open up this method here, you can see that we are setting this Boolean flag to false. Hopping back into our base component here, in our destroy method, we have our UI results show with win info, and we're going to pass in whether or not we are the user or not. So this is just going to detect whether the destroyed entity is the user base or if it's the enemy base. So depending on whether we won or lose, we're going to show the victory pop-up or we're going to show the defeat pop-up. So with that, let's review our flow. We have our game start button, which is going to be connected to our teleport logic. If we click that, we're teleported into our stage, and our map finder is going to initialize our stage logic We're just going to set up all our bases. And if we lose, then we are given this window here to retry or go to the main menu. When we retry, we are calling stage reset. If we win, so let's try winning here, we are shown our victory window, which is going to have the option to go back to the menu or go to the next stage. If we click on next stage, then in our stage logic, we're going to call open next stage, which we went over the logic for. And that's it. Our game flow is now working great. Our players can now transition from the menu directly into combat, and our stages reset dynamically. And next, we're going to implement a crucial optimization technique. We're going to finally go over building an object pool to prevent stutters as units are spawned and destroyed. Like we discussed, spawning hundreds of units repeatedly and creating and deleting entities cause major performance stutters. So in this section, we'll build an object pooling system. Instead of destroying dead units, we'll simply disable them and store them in a pool ready to be reused instantly on command. So creating entities on the fly is very expensive, and deleting them is equally as expensive. And the reason for this is because of what's called garbage collection. When we create an entity, that of course is using up resources to create those entities. When we delete them, what's happening is that something called a garbage collector is cleaning up those resources and is putting in work to make sure that that memory is clear. So rather than constantly creating and deleting those entities, what we're going to do, and there's a lot of different ways to implement object pooling, what we're going to do is just simply disable those, and entities that are disabled will be marked as part of the pool so that they can be reused. When they're reactivated, they'll be reinitialized with the proper data so that we can use those entities for the purposes that we need. So let's press play in our game start and let's take a look at an example here. So if you open up our main game, we can see that our targets are starting to spawn. And if we look in our unit pool, you can see that we've got units that are activating and deactivating here. And as I start to spawn my entities in and start to destroy some of these units in, you can see the enemy base. We can see as they're being destroyed, instead of being destroyed, they are just being deactivated. And you can see that as they're being deactivated, they're being reactivated as tigers. So essentially, our object pool acts as this kind of storage area for our entities. To manage our pool, we have a logic script called object pool logic, and we'll open up our desk here and open up our logics folder and locate this object pool logic. Double clicking this to open this up, we can see that we have our init create count. This is the amount of units to create at the very beginning of the game. And we've also got our unit pool, which houses our inactive entities for them to be recycled. So let's start with our get unit method. This is going to retrieve a unit from our pool. And we'll notice here that if we have no entities in our pool yet, then we're going to call create unit and pass in the init create count that we have here. So what this is going to do is if we have an empty pool, we're going to initialize it with our 5 entities here. So this is going to call create unit. And we'll get into this method in just a moment, but our create unit is going to create these 5 entities and it's going to initialize those so that we have at least 5 in the pool to get started with. Then we're going to grab a unit from our pool. We're going to call remove, and we're going to get the length of the pool so that we get the last one in the pool. And we're going to attach that to our parent. So our parent entity is going to be whatever we pass into this pool. We're going to pass in our parent entity, and then our pooled entity will be attached to that parent. Then we're going to enable our entity, because remember, the way that we determine entities that are in the pool and not is by this enable status. Then we're going to return that unit. So next we have our create unit method then. And in this create unit method, we have first our model entry ID, and we're going to find that by going into our models folder, right clicking and copying entry ID. And this is the model. We also have our unit pool entity. So if we go into our maps, main game object pool, unit pool. So let's just go into the scene here, object pool, and let's go back. Hop right back into our object pool logic. Let's close all scripts but this, just so it's easier. So here we're looking for our maps, our main game, our object pool, and our unit pool. And this will be the parent for our newly created units. So we're going to create the number of units that we've passed in. Remember, in get unit, we are passing in our init create count, which is 5. So we're going to create 5 of these unit models. We're going to call spawn by unit ID to pass in the model that we are referencing here. We're going to disable our unit to make sure that we're not actually utilizing this pool yet. And then we're going to insert this entity into the pool. So that will start us off with 5 units in our pool, and we're going to make sure those are disabled because they're not actually in the game yet. They're just being ready to be used by the pool. Whenever we are done with a unit, let's say the unit runs out of HP and it's defeated, we're going to call return unit so that we can return that unit back to the pool. So we're going to disable our rigid body components. We're going to insert the entity back into the pool. We're going to disable the entity. Then we're going to set the parent of this entity to the unit pool of our object pool. So this will constantly just move them back and forth between our target parent entity and this pool. Finally, we have our clear unit pool, which is just going to clear out this table of all entities in our pool. And that's it. Very, very simple. Let's press game start and see this pool in action one more time. So we can see in our main game, we have our object pool. Our units are passed into the pool, and they're going to keep switching parents back and forth between our enemy base and our unit pool. So our enemy base is going to spawn our units in, and they're going to switch back and forth between our unit pool and our enemy base. So that's everything for our pool. With our object pool running, our game can now spawn and reuse entities smoothly without stutters. Next, let's implement our currency system to manage stage-specific gold income and caps, giving our spawn logic its pacing rules. Now we need to add resource management to our game. In this section, let's set up automated gold income, add stage-specific resource caps to prevent players from hoarding infinite gold, and write currency deduction rules for spawning units. So let's press game start, and what we're going to be implementing here is the automated generation of our income. So we can see that our meso count is increasing. We also have a maximum of the number of mesos that we can generate. When we click on a certain card, we can see that the giant uses 10 resources. If we click on it, we can see that 10 is deducted, and we also automatically generate. So we can drop it all the way down to 0, but we are still generating income. So spawning a unit will deduct resources, and it'll automatically continue to increase. So the core of our currency system is based on 2 different locations. First, we've got our stage data, and in our stage data, remember that our stage data is managed by our dataset logic. So all of this data will be loaded into our dataset logic so that we can reference it in code. But I wanted to highlight 2 columns here. We have our player gold per second and our enemy gold per second. Both of these columns are going to determine how much resource we generate for both our player and for our enemy. So if we're in stage 1, then we're going to be generating 4 gold per second. If we're in stage 2, we're going to be generating 2 gold per second. For the enemy side, stage 1 will generate 1 gold per second, stage 2 will generate 1 gold per second. So we have different currency generation rates depending on the stage we're in. So opening up our component script. So let's go into our units and double click to open up our base component. And inside of our init, we can see that we have differing initialization logic for whether we're the player base or we're the enemy base. So for the player, we have our player gold per second. So that'll be this column here that we're loading in. And this will determine the gold per second that this base generates. Of course, this is also different for enemy gold per second, where we are loading in the enemy gold per second column instead. So in our update, let's go to our on update. We can see that we have our auto get gold method being called here. When we call this method, we are going to be running a timer where we have our gold timer that is tracking the current progress of time. And if that gold timer is greater than or equal to 1, meaning 1 second, and if our gold is less than the maximum gold, and again, this is coming from our stage data, and our maximum gold, that will be this column here, 30, 40, 50, and 50, depending on the stage that we're in. And as long as these 2 conditions are met, then we're going to first reset our gold timer so that we are counting back up from 0 again. And we're going to increment our gold by that gold per second value that we initialized up in our init method up here. We're also going to make sure that we clamp our gold value between 0 and our maximum gold so that we can never get more than the maximum amount of gold. And as long as we are not the user, we're going to use that gold right away and start our enemy spawn. So this is how we are generating our currency in our base. So for the enemy side, using our currency is very simple. we have our on update auto get gold. As long as we have enough gold in our enemy auto spawn, we're just going to utilize our gold. So as long as our gold exceeds our need get gold, we're just going to spawn in the unit. So this is going to keep deducting. As soon as we have enough gold, we're going to start spawning our units in. From the player side, it's a little bit more complicated because we have a custom deck and we also have different costs depending on how you've set up your deck. So let's go over that. First off, to start off our flow, we're going to open up our config file, and this is going to set up the default configuration of our game. We have our deck counts value, which is the maximum number of cards that we can hold in our game. And we also have the default user deck that initializes our first deck when we first join the game. So we have 3 as our deck count, and we have our default user deck to be Tiger, Bear, and Panda. We have 2 methods here. We have on begin play, which at the very beginning of the game, we're going to set our default deck count, where we have our deck count set to the default user deck. So whatever the number of elements in our default user deck is, that will be our deck count when we start the game. Hopping now into our UI, let's open up our UI editor and let's change to our main game group. Under this main game group, we have our deck container. So let's activate this property just so that we can see it. And we have our deck container that has a sprite GUI render component that will hold all of our cards in our game. Notice that we also have a scroll layout group component where when we start to add cards to our game, it will automatically organize itself within this panel here. So let's say, for example, in our models, I will just kind of start placing them to our hierarchy. So let's add these to our deck container. And you can see that it is automatically organized into this area here. So if I duplicate this deck item, we can see that the more I have, it is just going to automatically determine the layout based on the settings that we have in our deck container. So we have our scroll layout group set to horizontal. We have our spacing between our units set to 20. We have our child alignment to the middle center. We can change all of these to be the upper left, the lower center if we want, but we'll just keep these to the middle center. We're going to hide the scroll bar, so if we showed it, let's say always show, then we're going to see a scroll bar down at the bottom here. So you can see that we have a scroll bar here. It's expanding to the entire width of our entity here, but let's say I had duplicated all of these enough so that our scroll bar starts to shrink, then you can see that our scroll bar is automatically updated. But just for cleanliness, we are going to disable our scroll bar, and let's set the scroll bar thickness to 0. We can change the visual of our scroll bar if we like. We can set the background and various visual settings for our scroll. And then we have our scroll bar direction, left to right or right to left. And then for the vertical scroll bar, if let's say we set it to our vertical layout, then it will be bottom to top or top to bottom. Let's delete all of these, as these will be dynamically loaded in at runtime. And let's make sure to disable our main game entity. Also notice that in our deck container that we just looked at, we have a deck loader component attached to it. So this is going to be the brains behind what is loaded into this deck container. We have our init method here, and if we click show references, we can see that we have our UI underscore main game where we are calling deck init and calling deck loader init. This is simply just going to set up the UI for our deck. We'll get into the UI portion of this in a future section, but for now, I want to bring your attention to the fact that first, we're creating our registered deck item that just creates the models for our deck. We're going to be spawning 3 deck items as a child of ourselves, so it'll be created, spawned as a child of our deck loader, which again is going to be automatically organized into our layout group component. And we're also adding our spawn requester. So we're doing add component to this deck entity, and we're calling spawn requester. So if we look at our spawn requester under our deck folder, we can see that we are calling player base component request spawn upon this button click event. So whenever this button is clicked, which if you open up our deck item, we can see that we have a button component on here. So we're listening in on this button click event on the self. We're going to call player request spawn, which is going to call spawn unit as long as we have enough to spawn the target unit. And we're going to spawn in the unit, which will deduct our gold. And that is the setup of our deck. So in the next section, let's actually go into a little bit more depth of the deck editing system. So our economy is now working beautifully, and players will now accumulate gold, which cap at our stage limit, and spend it strategically to spawn units. So next up, as mentioned, we're gonna build our deck editor so that players can customize their unit lineup on the title screen and save their settings to the server. And we'll go into more detail about how the units deduct our player cost. Now let's get into our deck editor. So in this section, we'll create a dual panel layout to swap out units, write verification checks to prevent players from equipping duplicate units, and set up a server storage routine to make sure players don't lose their decks when they log out. Okay, so let's start by taking a tour of the UI. Let's hop into our title UI. Let's change here. And then from the title, let's check out the edit deck pop-up. So we already know that the edit deck button will open up this edit deck pop-up. So if we hop into our properties, here is our edit deck. And there's two different sections here. We have the decks pop-up, where all of our inventory of cards will show up. So these aren't the cards that are equipped, these are just the cards that we own. On the right side, we have the actual cards that are equipped and ready to be used in the level itself. So on the right side, we're going to populate our current equipped cards. On the left side, we're going to populate the inventory of cards that we own. For both of these, we're going to have a contents with the scroll layout group component. So this is going to automatically sort our cards into this grid here. So again, if I go into our deck item, I right click and I place to hierarchy, and let's drop this into our contents. We can see that it's being automatically organized into this pretty layout. If I duplicate this, we can see that it's duplicating and populating at this organized grid layout. I can keep on doing so until we reach a new line here, and we can see that everything is organized into this pretty grid. Same thing with the player decks pop-up. We have our contents, and we can see that we have a scroll layout group here too. So let's grab a couple of these and let's drop them into our contents here. And we can see that this scroll layout group is organized in a grid with a constrained count of 1 with the fixed column count. So it's going to always be a fixed column count of 1 so that we have this vertical grid layout. Each of these deck items has an image, it has the name of our unit, and it has the cost. In the parent, we have our button component, we have our deck component, we have a sprite GUI render component to render out the background. Okay, so let's delete these as we are going to be dynamically generating them. And let's disable our edit decks pop-up. So the first thing let's take a look at is let's hop back into our deck items model. And in the parent, we can see in our property panel, we can see that we have a deck component. We'll double click to open this up and we'll see what happens in here. So we have it's very simple. We just have a deck unit name, and then we also have an init method. So this init method is going to be called by, if we show our references here, it's going to be called in several locations here. We have our deck editor and we have our deck loader. We also have our player deck selector. So let's say, for example, in our deck editor, we are loading in our users' decks, and we're going to spawn in the deck model entry, and we're going to initialize our deck with our data. So if we hop back into the deck, we have our unit name that is being passed in, and we're going to assign this deck unit name property with the unit name that was passed in, and we're going to set up the data for this card. So we have in our dataset logic our unit data, and remember, in our dataset logic, we are loading in this unit data table here. So we have our name, we have the cost, and we also have the render ID. And if we remember, the render ID is based on this render data table, which has animation information. So these are all the RUIDs depending on the render ID for the idle animation, move, attack, on hit, dead, etc. So let's hop back into the deck. We are grabbing that unit data based on the unit name. We're going to grab the unit's render ID. From that render ID, we're going to access the unit render data table, and we're going to grab the idle animations RUID. Once we have that, we're also going to grab the cost of the unit data. So this is going to be grabbing that cost column. And with this unit idle RUID, we're going to assign that to our image's renderer. So we're grabbing the image entity amongst our children. So here we're going to grab this image entity, and we're going to grab the sprite GUI renderer component and assign the image RUID field to the unit's idle RUID. We're going to set the name of our unit to the unit name. So that's going to be grabbing this name entity. And then for the cost entity, we're going to set the unit cost. And then we're going to set the image renderer's playback speed to 0. So that essentially is going to pause our animation so that we only see a single frame and it's just stuck there. Okay, let's hop back into our maker. And let's take a look at our deck edit pop-up, and we can see that we have a deck editor attached to the parent of our deck edit pop-up. So this is going to be managing the actual edit of our cards within this pop-up. So if we double click to open this up, we'll take a look at what's going on. First up is going to be the temp selected decks, and this is going to store the name of the unit currently selected on the left side panel that is waiting to be swapped with one of the cards on the right side, which is actually equipped. Next up, we have our selected deck unit name. This is going to handle and keep track of the currently selected unit for both of our windows. We have our total deck content parent. This is going to be the contents panel, remember, with the scroll layout group on the left side, and the player deck, which is going to be the contents group, the scroll layout group, the right side. So we're going to hold the parents for both of those. We also have our player deck buttons, which is going to hold all of our deck entities. We have our OK button for confirming our deck edit selection, and we have the cancel button to cancel our deck edit selection. Okay, let's start with on begin play. So in on begin play, we're going to connect both the OK and cancel button. With the OK button, we're going to save our deck data. So this is going to save our currently selected decks, and we're going to close our pop-up. For the cancel button, we're going to do something very similar, except we're just not going to save, and we're just going to simply just close out this window. We're also going to connect the cancel button, which is going to call our close pop-up, which is simply just going to close this window without saving. Then we have two init methods. We have our register total deck. This is going to be the left side panel. So just keep in mind, total deck means all of the cards we own, and our player deck means the right side, the currently equipped deck for inside of the game. So register total deck is going to grab our unit data from our dataset logic. Again, this is going to be grabbing this table right here. And then we're going to double check to see if this unit is usable. So any unit that has an F in the title is not going to be usable in our game. As long as they are usable, we're going to spawn the model ID so that we're going to create a deck entry for that unit, and we're going to assign that to the total deck contents parent. So we're going to add a couple cards to this total deck contents parent, and we're going to initialize that with the unit name coming from our unit data table. So that's going to grab each of these names and initialize those. So we already saw the init method and what that does with the unit name. To this deck entity, we're going to add our total deck selector component. So our deck item has a button component, and to that button component, we're going to add different listeners. So we already saw that we have a spawn requester that we can add to this deck, but instead we can add different types of listeners. So for example, we can add our total deck listener like we're doing here, so that we change the behavior of our button click event. So rather than spawning an entity into the map, instead, we're going to mark this deck item as selected. So we're going to grab our deck editor. We're going to grab the currently selected decks. We're going to grab the unit name from our deck. We're going to grab the unit name from our deck, and that's going to be just the unit name assigned to this deck. And we're going to loop through all of the currently selected decks, and if any of those match the unit name, meaning that it's already been equipped, then we're just going to return. We're not going to allow the player to select it. Otherwise, we're going to set our deck editor's selected deck unit name to the unit name, marking it as selected, and we're going to activate our player decks. So if we activate our player decks, we'll hop into this method next. Then we're going to loop through each of our player deck buttons, and we're going to enable the button. So that's going to allow the player to click on the button. So let's hop into our play, and I'll show you what I mean here. So if we click on edit decks, we can see that currently we have the tiger, giant, and the panda. So if we select, let's say, the tiger, we can see that the right side are still disabled. We cannot click them to edit our currently equipped decks because we already have them. But if we select the bear, because we don't have that yet, we've now activated the decks, and now we can switch out one of our equipped items. So back into the deck editor, that's what our active player decks does. So from within our total deck selector, we're checking if we already have that equipped, and then we're going to activate the player decks otherwise. Okay, moving on, we are initializing our user deck. So here we're going to grab our user deck from our game logic. We're going to grab that same model. So this is all going to be utilizing this deck item, except we're switching out the listeners here. So we're doing the exact same thing. We are spawning in our deck model, but we're attaching a deck selector instead. So we had attached before, we had attached our total deck selector. This time we're going to attach our player deck selector. So what happens when we click on our player deck selector? Well, when we click on our player deck selector, so we are listening for our button click event on the self because our deck has a button component that is going to send this button click event to the self. So that's what we're listening in on. And we're going to just assume that we have a selected unit name assigned because from our deck editor, we are setting the activation status of our player decks to false. So the player cannot click on this unless they have a selected unit name. So going back into our player deck selector, we can see that we are assuming that we have our selected unit name, and we're going to init this card with the deck unit name. So we're going to switch up the currently selected unit, and we're going to set our temp selected decks with this deck index to the deck unit name. And then we're going to deactivate the player decks again. So that way we're going to make sure on the left side, we're going to click on a card. We're going to check on the right side if it's been equipped or not. If it hasn't been equipped yet, then we're going to activate the buttons. Then when we click on the right side buttons, then we can switch out the unit for that card and we complete the cycle. Activating and deactivating the decks on the right side to make sure that we are not doing multiple assignments of the same unit. Finally, we have our buttons. If you remember, we have the OK button and our cancel button. If we click our cancel button, we just close the pop-up without saving. So none of this will have mattered because we're just closing it without saving anything. But if we click on the OK button, then we're actually going to save our deck data so that next time we open this window, we are going to grab the currently equipped decks. So when we save our deck data, we are grabbing our temp selected decks and we're going to save our user deck. So we're going to call game logic save user deck. We're going to pass in the game logic's user decks. And if we hop into our save user deck method here, we can see that we are saving our decks. So we're going to first grab the first element of our deck, and our deck is going to just be a table of strings with the names of our units. So we're going to grab the name of the first unit, and we're going to save that to our save string. We're going to loop through the rest of the elements in our deck, and we're going to concatenate that with the save string with a comma. So this essentially creates a comma separated string of the names of the units that we have currently equipped. With that save string, we're going to grab the user data storage by that player storage key, and this is going to be a user ID key. We're going to get into where this is coming from in just a second. We're going to call the user data set and wait operation. We're going to save this string to the deck key. That is going to return an error code, and as long as it's successful, we have successfully saved our data. So the error code, if it's successful, is going to return 0. If anything other than 0 gets returned, then we know that we have failed this set operation, and we're going to log out the error code. So where is this player storage key coming from then? Well, we have this method called the handle user enter event, and this is an automatic event that gets called whenever a user enters into this world. So when this event is called, we're going to grab the entering player's user ID, and we're going to, as we learned in the teleport section, we're going to save the local player's name to the server based on that user ID, and we're going to also set our player storage key to the user ID. So that's where this value is coming from, and this is just going to be the user ID of the player that entered. Then we have two methods here. We have load user deck data and we have load last stage data. The load user deck data is going to load in our player deck. So if we open up this method here, we have our user data that we're going to grab based on our storage key. So here we're going to pass in that user ID. And based on that user data, we're going to grab our deck. So if you remember, we saved our deck to the deck key. We're going to retrieve it from that same deck key. As long as it's successful, we're going to call load user deck. So this is a server method. We're going to send that data down to the client and let our client know what the deck information is. So we're going to pass in our deck info. And as long as it's not nil, we're going to set our user deck and split it. Remember, we saved it with the comma separate value. We're going to split it at that comma, which is going to return a table of strings to our user deck. Otherwise, we're going to set it to the default user deck. If you remember, in our config file, we had a default user deck that starts the user off with the tiger, bear, and panda. Finally, we have our load last stage data, and this is just going to load in the last stage that the user has entered. So we're going to grab our user data based on the storage key, and we're going to grab the stage key, and we're going to call load last stage, which is going to do the same thing. It's just going to let the client know of the stage information. If we don't have a stage yet, then we're going to set the stage logic's current stage to 1, so we start from 1. Otherwise, we're going to set our stage logic's current stage to whatever the last stage was. So this makes sure that we are retaining data from session to session. So we start off from the last session and the last stage that we had cleared. Finally, in our main game, let's hop into our UI one more time. In our main game, we have our deck container, and this deck container has our deck loader component attached to it. So let's double click to open this up. First, let's make sure to revert this and disable this. And let's double click our deck loader to open this up. So we have our init method, and in our init method, we're grabbing that user deck. So remember from our game logic, we are loading in the user deck. If there was no user deck that was saved, we are again defaulting to that default user deck in our config. So with our user decks, we're going to first check the number of children in this container, and we're going to check how many we need to spawn. Then we're going to call register deck item, which is going to pass in the number of decks that we need to spawn in, and that will spawn in the models of the deck entry item ID. So that's going to spawn these deck items in, and for each of those children, we're going to initialize that deck with the user deck. We already saw what happens with the init method of the deck, and we're going to add our spawn requester component. We've already seen what the spawn requester does, but in this way, we can dynamically change the behavior of the deck. We've been using the same model this whole time, but we've just been switching out the listener. So we had a player deck selector, we had a spawn requester, and we had a total deck selector. So we have the same deck entity, but we're switching out the listeners so that they have different behaviors. Our spawn requester is just going to spawn in our unit at our player base. So to recap, we have our edit decks button. When we click on this, we have our deck editor. We have button listeners on the left side, and we have button listeners on the right side. Our button listeners on the left side is going to check if one of these units already exists on the right side. So if we click on giant, nothing's going to highlight on the right side because it already exists in our deck. But if we click on something that doesn't yet exist, then it's going to highlight up, allowing us to change the element from our right side. Let's click on tiger, and now our selection has changed. If we click cancel, nothing's going to happen. So our deck is the same when we load it back up. So if we stop play and we load it back up, we can see that we still have the tiger. But if we edit our deck and we click OK, then that saves our data so that when we stop play and we return, then our deck selection is saved and is retained. So that's it for our deck customization. Our deck customization and saving system is fully implemented now, and players can edit their lineups and their choices saved to the server. In our final section, we'll connect our UI elements together to manage our menus, combat HUD, combat HUD, and victory defeat screens. In this final section, we'll organize our title, combat HUD, and result screens into a structured UI group and wire up our game triggers to handle state transitions smoothly. So let's hop into our UI again, and we have three different groups. We have title, we have our main group, and it's hidden right now, but if we activate this, this is our main group, and then we have our result group. Result group is also hidden, so if we activate that, we can see that we have our result UI, which is going to contain the text for our stats. So let's disable our results group. So the reason why you might see some of these groups disabled is because this keeps our interface transitions clean and bug-free. So while we can toggle the active states individually of individual text buttons and different entities, it's a lot more efficient and clean to just treat this group as a whole and just disable and enable the entire group. So first up, the title. Let's go back into our title group. And if we look at the properties here, we have the game start button, we have the edit deck button, and we have the main title. We also have the edit deck pop-up that opens up when we click on edit deck. We've already taken a look at what these buttons do, but let's take a look at the controller behind what sets and connects these behaviors together with the UI. So the logic for our main game title screen is handled under our UI by the UI_title logic script. So if you double click to open this up, we can see some UI connections. We have our title entity, which is the entire group. We have our start button, we have our deck edit button, and then we have our pop-up. On begin play, we're going to connect both the game start and edit deck buttons to the enter main game and the show edit deck pop-up. The enter main game is going to call our teleport logic's teleport method into the main game. We've already covered what the teleport method does from our teleport logic, so I encourage you to hop to the relevant section for more information on how to teleport. Then we have our show edit deck pop-up, and this is just going to activate our pop-up and then call our deck editor component attached to our deck pop-up. So we have our deck editor component, and we're going to call init user deck when it is opened. And then finally, we have our show, which is just going to activate this entire entity. Hopping back into our main scene, let's switch to our main game now. And if you activate this really quick, we can see that we have our deck container that we saw populates our currently active deck inside of the level. We have our gold, which is going to show the amount of gold that we have. We have our stage text, which is going to show the current stage. And then we have our stage number, which is going to show our stage number. So let's deactivate this. And the logic for our main game panel is going to be handled by our UI_main game logics file. So let's open this up. And in the script, we have similar pattern. We have our references to our UI components. We have our deck container. We have our gold. We have our main game, which is the entire parent, and then we have the stage number. So our deck init is going to initialize the deck loader's init method. We've already taken a look at what the deck loader does. And in here, our deck init is what calls the init method of the deck loader. Then we also have our update gold text, which is going to update the gold text value that is displayed on screen with the value that we pass in. So that's going to grab the stage data's maximum gold and our current gold value that we passed in. We're going to make sure we floor that just in case this is a decimal value. And we're going to concatenate our text with the slash with the maximum gold. So it'll be the gold out of the maximum gold value of the stage. And then we have the update stage number text, which is going to update the stage text to the stage logic's current stage value. And then finally, we just have our show method that shows the current UI as a whole. Now we have one more UI group to go over, and that is going to be our result UI. So if we hop over to our result, and we activate this. Nothing too special at first sight. So let's just hop into the logic script, and that's going to be our UI_result logic script. Let's double click to open this up, and we have a couple references here. We have our result UI entity, which is the entire parent. We have our clear text entity, which is going to show the clear text. We have our defeat text. We have our clear buttons, and we have our defeat buttons. We also have a reference to the next stage button, the retry button, the to title button, and then the to lose button. So if we look at these individual UIs here, we'll go back to the scene and let's take a look. Let's activate our result UI again. And if we check and enable our stage clear, we can see that we have a different text entity for when we clear the stage, and we have a different text entity for when we defeat. We have different buttons for when we clear. We have next stage and two title buttons, and we have a different set of buttons for when we lose. We have a retry button and we have a two title button. So in our result window, we are just grabbing all the references from within our UI here. So in onBeginPlay, we're going to connect our stage button, so that's going to be the next stage button, to the StageLogic's open next stage method. That's just going to open up the next stage so that we can continue our gameplay. We have our retry button, which is going to call StageLogic's stage reset method. We have our toTitle button, which is going to be calling our self's toTitle method. So that's just going to return us back to the title menu using the teleport logic. And then same thing for when we lose, we're going to connect the toTitle button to the toTitle method, and it's just going to perform the same thing. We have our show with win info, which is going to pass in whether we won or lost. First, we're going to set our result UI entity's enable status to true, so we're activating our UI. And we're going to set our clear text entity's enable status to whether or not we win. Same thing for the clear buttons. If we win, we're going to only activate our defeat text and defeat buttons if we don't win. So a set of buttons for when we win and a set of buttons for when we don't win. Finally, we have our hide method where we simply just disable this result UI entity. And there you have it, the complete rundown for our defense game. So we've built a robust, highly optimized side-scrolling strategy game from the ground up, featuring an object pool, auto income, custom deck edits, server saves, as well as polished UI transitions. So now I encourage you to take this foundation and make it your own. At the moment, this is more of a framework that just provides base functionality and guides you towards the start of this kind of defense world. But you can add your own custom skills, create unique stages, or design spectacular events all on your own with this information now. So thank you so much for watching and happy developing!